Hello, I'm Anna Mackay and this video is on the product rule. So here is the official formula for how to calculate the product rule. And the product rule is used when you have two functions next to each other or being multiplied together. You might wonder what that derivative might be first. I just want to highlight that it is not where you differentiate the first and then tack on next to it the derivative of the second. That's not right. If you're interested in the proof, I'm sure there's one you can find on the internet or in your textbook. So the derivative is this. I'm going to add an extra note too that I like to call them the first and the second. So when you hear me say that, the first is f of x and the second is g. So the derivative is the derivative of the first times by the second, and then you leave the first and differentiate the second. And just a note on terminology there, it's called to differentiate, not derive. Derive is not an appropriate word in this sense, it's not the correct verb. So let's put that into practice. Find the derivative, dy by dx, using the product rule. The rule's down here in case you need a refresher. So we've got two functions, this is the first and this is the second. So let's write out dy by dx. So the rule is you differentiate the first and leave the second. So the derivative of this, you just have to differentiate the 3x, would be 3. So differentiate the first, leave the second, which is this one. And then you add where you leave the first. So that means don't touch it, just copy and paste and differentiate the second. So the second function is 2x plus 5. The derivative of that would just be 2. And so that's our answer for the derivative of that function using the product rule. The second function here, the derivative is dy by dx. I'm actually going to write this a little bit further down because I need the room. So dy by dx. So you differentiate the first and leave the second. So the derivative of 5x would just be 5. So you leave the second, so the second function, add where you leave the first, and now differentiate the second. Now this has a power there, so you will need to use your chain rule knowledge. So that means you bring the power down out the front. So we put that 4 in brackets. You copy and paste what you see there. Lower the power by 1. So 4 take 1 is 3. And then you differentiate the inside here. So the derivative of that is 3. Just leave it like that. Don't tidy it up unless you need to. Moving on. So finding the slope of the tangent to this function at a point. So we have to differentiate first of all. It's probably handy to write that function out with a fractional power as opposed to the square root. So I'm just going to do that. And now we'll differentiate. So the derivative is dy by dx. You differentiate the first and leave the second. Chain rule in both of these here. So bring down the power, copy and paste, lower the power by 1, lower that power by 1, so you'll get negative a half, and differentiate the inside. So you're just left with a 1 and leave the second. So you have to put this on the end. Now add, you leave the first one and differentiate the second this time. So again, chain rule, bring the power down out the front, copy and paste, lower the power by 1, so 2 take 1 is 1, so we don't have to write it there, and differentiate the inside. I will write that one there. Now, because we're going to go on and use this, we need to tidy it up. So how do I decide to do that? This will be at the top of this fraction and this will be at the bottom. So numerator and denominator there. So over this half, that 2 goes at the bottom in the denominator, and this is the negative half, so we'll have a square root down here. Now tidying up the second part, so we've got a square root here, the 2 times by the 1, so we'll have a 2 out the front, this under the square root times by x plus 1. Okay, so that's tidied up. Now we need to find the slope at x is equal to 3. So I'm going to write at x is equal to 3, and now I'm going to substitute in. Now, for my students who are heading towards a test without a calculator, this is excellent practice at substituting in a number and solving without using a calculator. So let's do that. So we've got our derivative again. So where we see an x, we're going to put in a 3. So let's do that. 3 plus 1. Square root of 3 take 2. So some of these won't be too scary. 3 take 2 under this square root, and 3 plus 1. Tidying up again. So 3 plus 1 is 4, and 4, I might just write that, 4 squared over 2. The square root of this, 3 take 2, that's just 1. Plus, what can we tidy up here? The square root, 1 again, and the brackets, 4. Keep tidying up. 4 squared, 16 over 2. Square root of 1 is 1, so 2 times by 4 is 8. Tidy up again. 16 over 2 is 8, so it actually wasn't that bad in the end. So 16. So just thinking about that in the context of the question, the slope of the tangent for that function at x equals 3 is 16. If you like this video, give it a thumbs up and subscribe to the channel, and the next video in this series will be called the quotient rule. Thank you.